Hello, everyone. This is Chi. I'm the co-founder and CEO of Kite AI. Here today, I'm very honored to be here with, of course, our dear Scott, my CTO, and Nelson, who is actually the guest today from Google DeepMind. And welcome to the AI on-chain podcast. Actually, today is the fifth podcast. So please welcome Nelson. And Nelson, please give intro to the audience.
Yeah, thank you. It's a pleasure to be here. Yeah, my name is Nelson. I joined DeepMind about 7 years ago. So right now I lead a team in generative media. So we work on image generation, video generation, etc. Um, yeah, that's uh, brief intro.
Very, very quick intro. Actually,
Very
I would
quick.
love to, too quick. Actually, I would love to
I don't
learn
know.
more about you.
Yeah, yeah, feel free to happy to get into more details. But yeah, there's a wide variety
Okay.
of things we worked on over the
Okay.
years.
Very
Yeah,
cool.
actually,
So,
yeah,
yeah.
actually, from intro, I have a very interesting question, Nelson. I think when
Yeah,
you joined DeepMind 7 years ago, that's right after the time of this AlphaGo, but before all
yeah,
this Gen AI stuff, right? I wonder
right.
what's the reason you joined DeepMind, and then how do you see the trending for last 7 years? I think 7 years makes like you probably one of the most OG guy in DeepMind.
Oh, I don't know about that, but probably one of the OG guys in Mountain View. So when I joined DeepMind 7 years ago, the headquarters in London, there's very few people in Mountain View, and we have like 30 or 40 people here. Um, and we know each other very well because it's very small. And most people don't even know that there's an office in Mountain View. Even people in London forgot about us. Um, so yeah, it has been a long journey from then to now. I remember when I first joined DeepMind, my very first project, I was on the WaveNet team, so we were generating speech and audio. And the idea at the time was, can we generate audio, video as well? So that was actually one the video generation at that time is very different. So we were using GAN models, etc. Um, but as you mentioned, DeepMind is a RL company, so we later transitioned to working on a lot of projects in reinforcement learning because at that time, I think the world's probably not ready for the generative media model yet because the ethics involved, the technique is not mature enough. Um, so we feel maybe we should invest in more in general intelligence in RL. And we did make quite a few success in like Mu0 and all that, following AlphaGo. This AlphaGo is the very first one, and then follow up is AlphaZero, Mu0, etc. So there's a lot of area in RL we can invest in. Therefore, we start working on that. But now GPT happened, Sora happened, so we keep on working on Gen Media since then.
So actually, I'm more also curious about like what brought you to DeepMind. You know, like
Oh, what
7 years
brought
ago,
I?
you
Yeah,
you
well, why I
yeah.
joined
So
DeepMind?
yeah, yeah. It's like the way like Scott said, like 7 years ago, it was very OG, very early. So you are
Right,
the true person who are doing AI before AI
right,
becomes sexy, right?
right,
So what
right,
you
right.
brought there, and what made that choice?
Yes. My answer may make me feel even OGer. So um, I actually before that I was at Microsoft Research. I was working on NLP. At that time, I feel we actually demoed to Bill Gates. There's a lot of language model at that time we can do. A lot of agent stuff we see today, we actually demoed to him like I don't know 10 years ago. We have live demo. It's very curated demo can carry out tasks for you, understand your intent, and all that. But again, it's the vision is there, but it's very hard to push the boundaries in NLP at that time. We just simply don't have the compute, don't have the scale of compute we have today. So, um, so leaving Microsoft Research, joining Google, joining DeepMind is one of those transitions that I feel I need something different. I want to work on something else. Um, where I had chatted with my current manager, he proposed the idea of video generation, I feel that's a very impactful project, a very cool project. I over the course of my career, I like to work on new challenges. I got tired very easily, got bored very easily, so I do switch things quite often.
That's very cool. So actually, you mentioned a thing that in like your comments on NLP's challenge at that time about computes. I'm curious right now, like uh, probably at this very moment, we used to talk about the top two challenges was compute and data. Did you
Yeah.
see like which one is becoming like a bigger bottleneck for given that recently like you guys had done very successful launch on the video generation model VO, by the way, congrats on that,
Thank you.
getting
Yeah.
tremendous positive feedback from the market. So
Yeah.
I'm curious, like if you see which one is more of a bottleneck right now, or it's still the same level?
Um, well, I think the bottleneck on both, but you have to pick one. I would say compute because if you that's the lesson from AlphaGo. If you think about the very first version of AlphaGo, it's trained on human data, player data accumulated over many years on the online game playroom. And then when you move to Alpha Zero, the zero symbolizes there's no human training data involved. All there is the goal is self-play. It play games against itself, and then they learn from that games. They don't need any human data at all. Simply compute, and you can have a model that can beat AlphaGo 100 to 0. So that's like if if you can scale compute infinitely, which means you are able to gather data from yourself, to gather data from your interactions, and you can solve the data problem that way indirectly. So if you have to pick one, I would say compute is more important. However, compute is growing relatively slower pace than we would like to be, and also very expensive too. So in the meantime, so we should leverage whatever data we have to make it feasible.
So, Wilson, I completely agree with you here, but I think also it's use case per use case different because AlphaGo is a Go-based. In this case, you can just generate from scratch. And then
Right.
if you look at another scenario like a robotic, like in
Right.
this case, like for example, robotic robot, like NVIDIA shares their GTC conference, they are building this data pyramid, and then they have 1% of actual real robotic data, robotic operating, but it's limited by 24/7 per robotic in this case. Like you generate 24/7, and then
Yeah.
they use compute to generate. They have 1% of data. They duplicate this data, generate like 100x this synthetic data, and then this is actually the second tier of synthetic data. And then at the bottom was a large language model, all this common crawl data, this data like give robotics some common sense. From that perspective, I think data play a much more important role. I think
Yes.
yeah, like I think computer game or these games like more like a control environment. This simplified scenario probably different than the most of the real world use case. I think.
True. True. But yeah, because I totally agree. That's why we say like if you have to pick one, if you don't have compute at all, you have lots of data. Of course, you cannot do anything. But if you have no data, you have lots of compute, there's something you still can work with. But I agree, yeah, that those are super important. Yeah.
So you guys are not too worried about the pretty much like a Meta acquired scale AI type of thing because we saw like a
Oh,
Google want to like a cut the potentially cut the the
yes, yes, yes. So scale AI or other things, I think that's also an interesting question that if you think about human babies, they don't talk, like they don't know language. Going through the real world interaction, they can acquire the ability to talk. And they can acquire pretty much every like AGI by simply interacting with the world. And I feel that's where the compute scaling comes in. And where scale I think they are in a interesting situation where now the model are getting so good that they can label a lot of data even better than human or faster than human. Now, that's an interesting situation where I don't know how the company interact with the rest of the world. So yeah.
I see, I see. Yeah, definitely this reminded me even like a few years ago, we start seeing like in the market, there's more sort of uh, like the scale AI competitors are calling themselves with a more AI generated data, like a data labels and especially with a supervised, like, like or semi-supervised way. But yeah, so for example, like Snowco, I remember when they were uh, uh, when they funded a few years ago, one of the key challenges they're trying to solve, what scale AI is not solving at that time, was like replacing a lot of the human steps with machine learning or like AI algorithms in between. Yeah.
Yes, yes. Because a lot of times I think it's not just replacing, it's something that humans are not good at. Like for example, when we do video generation, let's say we have to compare the quality of two videos. Um, those are tiny artifacts are unless you're watching full screen, you wouldn't be able to spot them. And very easily you get very noisy results. For professional eyes, you can see, oh, that video has this artifacts on the left edge. But for most like average readers, they don't watch in full screen, and they probably wouldn't spot it. In those cases, maybe AI or even simple model can do a better.
I see. That's very interesting.
That's a good point. Actually, another startup called LLM Arena from Berkeley just got 100 million investment. It's also a startup. I saw the investment. It's also a company from Ian. Ian, the founder founded Databricks and then a few other companies. I think this is actually super aligned with the trending recently, like with reinforced learning. Really, finally reinforced learning. And then if people are thinking about we should have evaluation first, have a design model there is also a researcher from OpenAI said the second half of Gen AI is evaluation first, like design evaluation first and then train the model, along the way. And then I wonder, what's your view on the recent, reinforced learning part of it? I know you are expert in this part. I want to, learn more about your opinion here.
Yeah, I really like reinforcement learning because I feel reinforcement learning is almost like a real life where you have an agent that interact with the real world and it continues getting feedback. I think in early explorations like AlphaGo, where you have a fixed game setting that the reward is signal is very clear. Now we are moving into a world where the feedback is unclear. um, even for human, like let's take human for example, in the same social setting, same sentence, maybe some person feel comfortable, some other people will feel uncomfortable. So in that case, their reward to their own brain will be different, right? Depends on their motive, depends on their preference. We are agents. Now we are in a very interesting situation that how do you design the agent to take this preference, this very dynamic rewarding system that is not controlled the gaming environment. It's unclear what this reward is. Um, Still, the RL needs to step up the game. No pun intended. But previously, the game has been simple, but now the game is much harder. I feel it's a very exciting area to explore.
I wonder also, if you think about AlphaGo, it's a deep neural network plus reinforced learning, and then it proved itself like 9 years ago. And then if you look at the recent last year-ish thing, and then we saw another, transformer plus reinforced learning, and then this new reasoning, reasoning reinforced learning. Um, as Miao said, as you're in DeepMind for all these years, like what's the difference between this reinforced learning under different architecture, and what changed and what didn't change? And we know reinforced learning has been here for, I don't know, 30 years in this case. And then, what changed
Right.
and what didn't change? Yeah.
So at that time, I feel it's very hard for people to understand the agent. And the agent action space are limited to smaller things, like predefined things. Like at that time, we don't have a language model. Um, the agent is not I don't know if we can consider them almost intelligent because it cannot speak. People perceive intelligence through communication, right? So now we cannot communicate with agent. It's only just doing things very smartly. Um, it's almost like a calculator. You can calculate all of it correct, but you don't consider it intelligent. Um, so that's where AlphaGo comes in. At that time, we need a playground to prove RL works. It would be good to have the agent be able to speak, to explain what it is doing, and have some inner thinking, reflection, and all that. So we can actually reasoning. We can say, why are you doing this? Like, why are you making the decision you are making? But we don't have that capability at that time. The language model is simply not ready yet. Besides AlphaGo, probably less famous work, there are other works like can you have a multi-agent system play other kind of board games, like which requires some negotiation. Like for example, Settlers of Catan, where you have to trade resources with other players. Now, even that, you can predefine the action to some predefined templates. Like I want to treat one sheep to your 5 wood. Not I can just fill the numbers, right? But it's still the negotiation lacks the thinking behind it. Why are you doing this? It doesn't have the like convince the other person. You don't make a point why this is worthy of the trade. You are leaving the other agent to understand your position, understand their own position. There's no persuasion happening. It's just still a very naive way of negotiating. I think there's a fundamental difference in this case. Now we have a language where language allows us to peek into like the thinking process to understand what agent is doing, and also potentially interacting with not just agents themselves. They can communicate with humans, which makes the field way more exciting.
Yeah, so that's actually where yeah. So Chitu, go ahead.
No, you go ahead first. Yeah.
Yeah, so I think that's actually a very interesting thing because I also, when I was in graduate school, I built a small reinforcement learning. I found that most of the time you just don't cover that. You don't know how long it will run, and then it only works in a known environment with all the full information. So that's why it's always working in the like a small game. I'm a Catan fan as well. So in this case, I totally understand. In this case, it's like a multiplayer negotiation, multiplayer, this game series stuff, like gaming stuff. But I guess as you mentioned, the difference for last is that you have a foundation model who can reasoning and who can actually think as a human. And then from certain perspective, an interesting perspective on that is that this foundational model may be just a small control environment in just the language and speaking. In this case, because if your large language model is just it's also like a gaming environment. It's like a general game, like control environment, general game in this case. And then if they do, like a reinforcement learning, that's really well. They have some certain type of intelligence, and maybe you can further expand it to other action like robotic. I think from certain perspective, this makes sense and interesting, I think.
Yeah, and also goes beyond the ability to communicate, also knowledge, right? So AlphaGo back then can only do AlphaGo, like can only know Go game. Now it can has world knowledge internalized in that model, which makes it's also more interesting.
I think from certain perspective, it has a knowledge about language in this case, but it's people can further associate language to real world experience.
Right.
Yeah, so actually, I'm very curious. Goes back to one of the comments you made before. That's like one of the challenges you see that still about agent, which is kind of like what Scott mentioned, Shun Yao Shunyu from the OpenAI researcher mentioned the second half about evaluation. As you say, like the agents right now, one of the challenges is the real world tasks are still very complex and case by case for agents to operate and how to evaluate that. So there's multiple proposals that people are talking about. Even like in that articles, I think some of the ways is either you do, like all the evaluation, again, like just independently, like for each of the use cases. But that means it's going to be probably you have to set up a lot of like different environments and testing across different ways. Or another way is like, sequentially kind of like just have like automatically, but sequentially let them do one by one type of evaluation framework. So I'm curious, do you guys right now, do you guys see any like proposals, like good ways for evaluating agents and also like make agent working better? Because right now it seems like even though people have been talking about like multi-agent system for a long time, but still that system, the accuracy, stability, and everything still have a lot of question marks from people when come to business world really want to use those agentic systems. So yeah, curious about what you are thinking of.
Yeah, I think the task like evaluating agents at this point, looking at the metrics, they are largely aligned with like a task, like why people do with agent, because they want to carry out some tasks on behalf of them, on behalf of the user. So a lot of the metric is centered around the success of those metric in a certain way. Like you have a flight booking agent, you can measure like is this flight satisfy user preference? Is that what actually economically possible? Does it make sense? And things like that. But I think that's a good way for product to advertise to users, almost like a real world agent. You have like a real estate agent. They can tell you, hey, I sell a house very successfully. Here's my track record. You can use that as advertise. But I think when you go through the model training, you are more normally goes back to how can you scalable in a scalable way to create the fundamental capability of the model. And well, there's certain metrics you want to keep track, but a lot of those metrics are a byproduct of increasing the general intelligence of the base model or the agent capabilities. Like for example, for realtors, maybe they went to college, they learned mathematics. I don't think when they were in that classroom were thinking about, oh, like 10 years down the road, it's gonna help me to sell to sell houses or something like that. I feel there's a lot of things there. I think pre-training is almost letting the model go into a school, um, learning all the basics, to learn the mathematics, to learn language, to make them get to a point where they can go learn stuff on the job through interactions, and then they can further fine tune for that specific metric.
Yeah, I felt like what you are talking about is I felt like a debate or like basically people are talking about how do you build a successful and sustainable AI startup? You don't want to build something that's one day foundational model improve and then you're all screwed because all the improvement you did is just then once VO launched the VO4, then all the improvement that you did was meaningless before.
Yeah.
So actually, this is I'm curious, like from your perspective, because I felt like recently, like some of the like conversations or podcasts that I was listening to, more and more people are talking about like how like if you want to build like agentic solutions or agentic products, one of the key things you have to do is frame like usually because we're talking about more verticalized agents for like verticalized business problems. And usually one of the key things you have to do is indeed like have a very good like a benchmarking evaluation solutions there, more than just like a normal way that human come in. For example, like what you talked about, like the flight agent, in order to do that evaluation, say is that preference that the human has. Initially, usually people just do that, let the real person come in to say, is this your preference? Is this something that you like? But this will not be scalable in some way because you always have to have human in the loop. But that's why they're talking about that. Like this should be one of the key components if you want to build a verticalized agent companies for a business solution or
Yep.
problems. But I'm curious, like, since you are talking about foundation model capability and you come from that background, is there anything that you felt even like no matter how foundation model is improved, the startups or like other companies still have a space
Yeah.
to survive because the foundation model cannot cover that.
Yes, yes. Yeah, I think there's always like that, right? Like I think I keep the analogy I have made before, base model pre-training almost like going to university or going to professional training, whereas the company where you have a startup, there's always gonna be the last mile adaptation to what user need. And also when you get to a point, like think about like all the real world decision. Either we hire a real travel agent like we or real estate agent, we don't really think about like are they the absolutely the best in their job? Therefore, I'm going for that. There's a lot of other factors into it that decision making. Maybe accessibility, or maybe they're more friendly, or there's other UIs are more friendly. As long as the basic capability pass a certain bar, and then other factors start playing a role. Um, for example, when you have a company, you may have a travel agent, you may have a pipeline of agents that you interact, or maybe you know my history, you know my preference really, really well. Or maybe I have been using your service since I was 10. You have all the history within your company, and then you know all my information. Therefore, I don't have to reiterate all my preference again and again and again to make my life easier on this agent. So there's a I think there's a long tail of things that user can do, and there should be very successful startups built on top. It's almost like you think about Facebook running on AWS or yeah, the foundation model, foundation infra we can provide, but there's also a lot of value on top that you can enable. Probably the top layer maybe eventually make even more money than the base model. We are not there yet. I think we are now still building the infra, building the road. Feels like all that important is like road paving machines, but down the road, car is going to be more important.
Yeah. Yeah, so I completely agree with you. I think the secure AI Ascent just happened like a weeks ago. And then the idea is always same. So like application layer is always the biggest opportunity. It's same with mobile, it's same with internet in this case. It will start with infrastructure, but application layer is definitely the biggest opportunity. And I'm actually very, very, I call on this point that you just need to be good enough. Because I remember I'm not a Go player, but I remember 9 years ago when I, AlphaGo comes, and then I just follow every single, I actually learned Go, along the way. I follow every single comments on the Go. And then a lot of extremely professional, the professional Go player, extremely talented professional Go player say, hey, we always define this as a guardable Go, the guardable Go. Like always make the rightest move, like the smartest move in the Go. And then their evaluation is that AlphaGo is not the god of the Go yet, but it's good enough. It's good enough to beat every single human. AlphaZero is good enough to beat AlphaGo, 100% success rate in this case. As long as it's good enough in this case, it's not perfect. It probably never be perfect, but it's good enough, it's good enough. Similarly, I think the last few months I'm building, my personal agent help me order Uber, help me book my calendar, help me book a book trip. And then I found there is a very marginal difference if I switch from cloud, Sonnet 3.7 to 4, or maybe even to a DeepSeek R1 model from certain perspective. I feel like it's the difference is marginal in this case. And then previously I think that's why I like to use the example, like the foundational model is like the engine in the car. All you care about is that I want to go to the airport. In this case, people care about engine because previously the engine is so bad. It's like some crappy engine cannot deliver you. But later on, as long as you reach like V6 or V8 engine, no one really cares where this engine come from. You can switch engine easily. As long as deliver me to the airport, I don't really care what engine.
Yeah, and then once you get to that point, you care about if the state is comfortable, how the stereo works, yeah, all those other things become a factor. And also, I think agents really unlocked. I think as a human civilization, that we really unlocked computing potential. Like I think in the past few years, well, in the past few decades, the computing power is growing almost exponentially. Or yeah, so um, the human brain is we cannot grow any further. So our ability to control compute is it's difficult. Like we cannot scale the same rate as computing scale. And therefore, we have the whole field of HCI. We're trying to make computing accessible to human brains. So we actually have an entire industry, almost like waterfall industry, like one industry, the invention of computing, like programming language. Like why do we need programming language? Because we need professionals to write a program so that easier for people who don't understand computer to leverage the underneath computing infrastructure. So now with agents, it's going to be very different. Agents are inherently computers, so they can actually understand. Like that's why when you have a really hard problem given to an agent, agent can write a program to try to solve it. That's not normal human would do. Like, why would you solve like a mathematical problem? You write a program to solve that mathematical. It's just overkill. But for agent, maybe that's simpler for them. They can write a program like no tomorrow. But again, that speaks the question like, why do we even have programming language at all? Like, if it's an agent, they can write assembly code directly, right? Like why is it writing Python, which is intended for human to use? Maybe it's easier for them to generate machine code. Yeah, I think it will be a very interesting area to live in.
Yeah, no, so I found this is very interesting because the programming this high level abstraction programming language was generated to make user easy to easier. Like for example, if if people learn compiler background, you have this as you mentioned, assembly code which is not readable, human readable, and then it's very easier to blow off your feet, in assembly code. Then people invite this high level language programming language like C, and then people found it's still very easier to have this pointer memory, this terrible things happen, and then you have C++, you have all this high level Java, Go, Rust, all that make it safer, make it more abstraction. I think from certain perspective, I don't know if you're going to working towards this large language model general assembly code because it's not readable. It's not like there is a reason the language, the programming language more and more like English.
Yes.
Like English we speak. Like particularly
Yeah.
Python is actually one of the best. More like a speaking language. I don't know if you're going to work backwards to that, but yeah, I can definitely see the point here.
Yeah, but that means, like, for example, the UI aspect. We have a professional, we have the entire software industry trying to use programming language like Python, make it computing more accessible to like my mom, for example. She doesn't her ability to interact with underneath compute hardware is through like a touch screen. And even that is more too complicated for her. Like there's menus and there are things like you have to give her really detailed instruction. You have to go to this menu, this corner. There's a hamburger thing you have to click on. But now agents can do all that. Like we don't need to go through this UX phase. Maybe bypass all that, go directly to the programming language, or go directly to the bare metal where it's underneath compute. Which means that we can leverage compute way more than before. Like for example, previously, if my mom want to command a 1,000 machine cluster, she doesn't have the ability to do that. Someone had to write a code for her so that she can do that. But now she has an agent. Agent
Yeah.
can do this program for her, command 1,000 machine cluster, compute like what's the best price of this vegetable, and that can be useful for her to make a daily decisions.
I do feel like
Go ahead, Scott. Go ahead first. But I do have some
sorry.
questions here to discuss. Yeah.
I was chatting with team internally. I found this has become a common pattern. Is that previously you have, previously people write code, people use Gen AI generate content. But nowadays, I felt like a common pattern is that you have Gen AI generate code on the fly, and then
Yeah.
you have the code generated and then execute, fetch data from elsewhere, or even generate the data and then just execute. And then people don't want the code generated. People want the final result. And then
Mm.
this is actually at a very early stage. If you look at the ChatGPT, currently not optimized for this. I guess most of them are consumers. They probably don't care this. But if you look at the cloud, now they have this artifact. You can display code separately in a separate column, and then you have Manas and few other. They also list the code that generated code as a separate column. But this is still very low efficient. For example, if I do some experiment and then say, hey, I want to have my cloud order food for me, and in this case, and then it will generate a UI, and then it will call the corresponding Uber and Uber Eats. The generated UI code part will take like a minute because
Mm.
it's
Yeah.
only
Yeah.
output like a few hundred tokens per second. It generates the whole page. It's gonna take a minute, and then
Yes.
I guess I feel like one future direction here is that you're gonna have tons of optimization between this code and data execution in this case. Even though you still
Exactly.
have Gen AI, yeah, you have Gen AI generate code on the fly, but that could be much more speed up and much more efficient, I feel like.
Exactly. Yeah, like it doesn't make sense to generate a Uber app from scratch every time you order Uber. Like that's just not efficient. So there's a line you draw. If for certain tasks, of course, you can do that. But so for other tasks, you want to leverage the existing infra as much as possible. I think the I think this is the interesting point where agent is at this moment coexist with human. So there are times they have to adapt to us rather than we adapt to them. So in this coexisting phase, that the agents are behaving more like humans. So we have to do certain things so that we can debug, troubleshoot, or maintain the agent. One maybe when we get to like super intelligence, the the agent doesn't need human anymore. And but at that time, this is how you get there. Maybe the capability still is in it. If you're going back, maybe that's not the best way of designing agent. Maybe that's not the most optimal way. But because of this coexisting phase where it has been like this, like for example, in North America, we build house in certain ways. Like in Europe, every house is like bricks and concrete, where in North America, you build with like wood. That's because the abundance of wood here, right? Once you have the the know-how, I have the moment, and all the builders know how to work with wood. You have this ecosystem, and then later on, it's very hard to switch because you have everyone knows how to do this now. Even though maybe that's not the best way, but because of the situation, it becomes best.
I'm actually very happy both of you guys are touched some of the questions I want to discuss. So basically, what I was first the thing that I was trying to collect your thoughts, Nelson, was like now we see again like a great future that everybody have a high expectation on agents, like all the things you say like your mom can just use agent to do all those things without even touching the screen. So I
Yeah,
think everybody is like expecting or like dreaming that this future will come, or hopefully even like come soon. um but like we're also talking about there's some challenges, like again evaluation was the one we touched a bit, and we also saw a lot of like the progress people made from like OpenAI launched that function calling and then MCP and then A2A and all this stuff. So the first thing that I was, the first question I was trying to collect your thoughts was, did you see any other difficulties that or like challenges, the probably like the biggest or like second biggest unsolved challenges right now to go to that future? And I'm very glad that Scott actually already mentioned something he's observing right now. For example, like the code generation is still not fast enough and everything. Even though, Scott, I do think like one of the things recently, like like by chatting with people and see how they're deciding different like tools to use, especially come to like say developer tool, like AI coders, I think one of the things that actually make people feel more comfortable is they see the progress, like end by end to end by themselves, because people still have not enough trust on like the all the like a black box, like computer have agent where like AI generates code and all the stuff. So in some way, actually, that's is one of the design philosophies for some products right now, trying to be what very like transparent about how the process looks like. But of course, like the speed is indeed a problem, probably like what Scott mentioned. But anyways, I'm just curious, like where we are right now from your perspective, that is still a big blockers for we march towards the future that your mom will solve all her daily life problems with agents.
Yeah, in a way, it is already happening, right? Like I think a lot of decisions we make day to day, if it's good enough, then probably that's like, for example, using Google Map, when she says from A to B, is that route the absolutely the best route? Probably not. Maybe there's some way that she doesn't know. Maybe there's a better way to get from point A to B, but as long as it's reasonable, it's good enough, then she will rely on it, and she's comfortable following the instructions along the way. And um, I think now what happens in AI, a lot of non-mission critical decisions, I think she's already relying on AI helping her to make that decision. Um, because I don't know if the alternative is better. Like we as humans, we don't always make the optimal decisions in our lives because we lack the context, we lack the information, right? Um, so I think now we are in a transition where people want to rely on it, but I also have certain doubts if they are correct, which I think is probably the best way situation we are in, because if you're 100% relying on agents to make all the decisions for you, not double checking or not having these doubts in it, that can also be dangerous, right? So where I see the current agents have, I think there's two things I feel is lacking. One is the control over quality. For example, if I need to make a decision, if I'm in a life-threatening decision situation, I need to make a decision right now. I can't wait for like 20 minutes to generate the code execution. I need to find out escape route. Like there's a fire going on. I need to find out like ways to get out. So maybe that's the decision in those situations. I can control. I can live with approximations. I just need to do something. So waiting there, not doing something, is worse than doing the wrong or a little bit the wrong thing. So that's it. But in other situations where the stakes are high, I'm waiting for the model to work a week. Tell me next week. Do all the progress you want and do all the research you need and come back next week. But when that happens, I expect really, really high quality results. Um, right now, we don't see benefit from letting the agent run a week because from where I can see all the agents, you let it run for 10 minutes versus a week. You probably get a roughly the same results. Where is that shouldn't be the case. The reason is behind the scene. There's a lot of things you can do in that 1 week. You can run experiments, you can write code, you can even do A/B testing, do certain things in the real world to make your results more accurate. I think that can be very useful. Yeah, the
Actually,
second thing is probably reliability. That's where is AI agent or making a decision that's reliable, predictable, so that I'm comfortable with that decision. Like this is kind of weird, but also true. Like you talk about AI or touch screen. If a touch screen only works 90% of the time, you actually feel very frustrated. Every once in a while you touch it, it doesn't respond, and you're very angry. Agents are almost like this now. You want to rely on it, but for that 10%, it just doesn't work. It tells you, I cannot help you. It tells you, for whatever reason, they're like really awfully wrong. And that's the moment you realize, oh, you're not 100% there yet, or 99%. You do feel that. And then for that 10%, you still feel annoyed.
yeah, Miao-sen, actually, this reminds me of a paper I read like last week. I actually found the paper and shared here. And then, so the paper says that the average time, so the length, the task length for AI agent to reach 50% accuracy currently is roughly at 45 minutes in this case. So around 45 minutes, like a Sonnet 3.7. This is actually a paper last month. Sonnet 3.7, they can reach like a 50% accuracy around operating for 50 minutes. The thing is that it's almost a double every 7 months in this case, because it's doubling from like 7 months ago. It's only like 20 minutes, and then from this trend, it's most likely going to doubling every 7 months from now. So in that case, it probably still take 3 years, for agent to operate a week, like with a 50% accuracy. I think the technology is not there. Not means that, my argument point is technology are not that accurate enough, but working to their very soon in this case. And if agent can operate as a reasonable accuracy, and then for a week, we might actually have enough work for them to do in this case.
Yes, exactly. And I think agent, we're getting to a point that agent can do a lot of things. So a lot of things are at their exposure. Like they can do a lot of toolings we build around agents, right? They can access the real map data. They can access to weather. They can access to, I think they can access to computing. The Python code probably the most important thing. They can probably write a program to access everything else. But now they do get access to real time information, and gradually they can probably can perform social studies to make a good decision. Like for example, right, obviously we want to run ads. Give me the best ads campaign, and they can potentially do a small scale somewhere in the world we don't know about. They can do some sort of survey behind the back, and they can collect additional information which is missing, and that can complement and support your decision making. This is actually what we expect when we hire someone to do this kind of tasks. Like we not just what's in your head right now, but also I hope we can get to you can do additional work beyond what's in your head and give me a better result.
Yeah, that's actually, like I think again recently, yeah, one of the most, like sexy futures that at least to me, I felt like it sounds very sexy. Is like again, everybody can then in the future hire like whatever agent to do like the thing that you want, right? Like you can hire them,
Yeah.
and that they are, yeah, more than just a junior person. They will do additional stuff. For
Yeah,
you.
that comes down to the evaluation. Like, can we really evaluate agents in those settings? And I don't know. It's hard. Like, is there a right or wrong answer in a lot of decisions? Because we don't have, like, for example, me joining DeepMind, is that the right decision? Because I don't know. I cannot live in another parallel universe to justify this decision. So I think that's where in the real world setting, it's messy. It's not like a game that you can do a lot of control studies. And the agent is operating in a human society, and a lot of decisions they make is cannot be measured in terms of like magic numbers. And this is, I feel, this is very, very hard.
Yeah, but that's also why actually, like while you are talking about, how in the future, like basically, I think a lot of things seems like the challenge or like the gap, especially the accuracy gap that we see the agent is not able to deliver reliable and predictable solutions somehow still boil down to the underlying, let's say, foundational model. It's still not good enough, not able to, like reduce the hallucination at the model level. But like then, even like now, when agents go out to select, if you give them a big pile of like MCP, they probably will get lost at the moment still. So, but besides that, just like human society, that we're like you talked about how agent right now is building coexist with human, but in the human society, besides human brain itself, which is alive, which is kind of like a foundation model alike, besides that, our own self, is there any other things that like built around the human society or like built on internet that actually makes like the human hiring process or like human collaboration process more like smooth. So, for example, like when you're talking about, or when you Scott discuss about like the agents, again, like will they be able to deliver that more accuracy by themselves? What if, for example, the other side, if they are going out to choose, like say, MCP or choose some other agent to collaborate, they already see some of the, like say past behaviors or like the past, just like we have our credit score, so that the loan facility can decide how much loan I will give to you, type of things. Of course, it's a little bit like not now, because now you have to make them usable first, but that goes to another like a whole level of if the future is like agent dominated rather than like human, like you said, super intelligent, probably don't need that many human involved in the process. Then does that mean we have to rebuild the whole, or like we have to have a whole infrastructure built around the agents to make the collaborations process more smooth, beyond just the foundation model improve themselves?
Yeah, I feel MCP almost like the LinkedIn for agents. So it's agents list a little bit information about themselves and allow others to understand better about themselves and what they can do, what they're capable of. And if there's new updates come, they make a podcast to everyone, hey, I'm joining a new company or whatever, have a new position, and let everyone know that this thing changes. Yeah, I feel MCP almost like LinkedIn. Maybe agents gradually need a social network like LinkedIn.
That's a good point. Linking of agent. Think about it.
Yes.
Like you will list all your hired, like your work experience before. That's amazing.
Exactly.
Actually, if I think about it.
Yeah, you can say agents are friends with each other, and yeah, they can collaborate together. Yeah.
This actually become reminding me like the agent Tom that Stanford University was
Yes.
experimenting. But that was from like a personal lab perspective. But yeah, like professional work is another important piece as a human
Yes. Yes.
yeah.
But it satisfies the same underlying demand. Like we need to understand the agent. We all need to understand who are you. Like if you put a person in front of you, you need a resume to understand. Um, in human society, we kind of related like using the like why do we need social network? Why LinkedIn is useful? Because you have this social pressure. If people lie about what they do, your social circle kind of cross checking the information on your LinkedIn. If you say graduate from certain university, I never went there, and it's kind of weird that people can know like what's wrong with you, right? And agent world, maybe that can be the situation as well. And like people say, I tried that. You claim you can do math. I tried it. It doesn't work. You can give all this feedback about the other agents. Yeah.
That's definitely very cool. Anything, Scott, you want to share your thoughts here, or
Actually, I want to chat more about the video model, and then in this case, actually,
sure.
I went to there is annual CTO summit every year, last month, and then Andrew was there. Andrew and Jay shared his latest observation. He mentioned there is a 5 trend that's very interesting, like AI code assistant, video model, audio model, data processing in the new gen AI world. A video model is actually one of pretty high, priority. And then, since you have, spent last many years on this video, and then which is actually the best, one of the best gen AI video model, I definitely want to hear what's your, learning from it, and what do you think, like in this case?
Yeah, video model is a very interesting field because I like it because it's a way for human to receive information. It's a very high bandwidth communication channel for humans. For example, when people when we like nothing replace a watching a video rather like a tutorial or something like that rather than reading text. I feel as a communication method, sure we need language, but that's just one way of transfer information or communicate. Um, so I don't know how many people still read books versus watching the TV adaptation of that book, right? Like I think the level of audience is just not proportional. So the fact that we can get a video model out, I feel Right now, we are tailored towards creatives, where you can express themselves more about what's their creative ideas, but underneath they're trying to convey information and trying to convey their emotions, their feelings, their point of view in the world, their opinions. But I think gradually they become a way for agents or models who can talk to real people, rather than give you a document about like 10 pages. Go ahead and read it. So 'cause that's what happens to deep research. You ask them something, give you a 10-page document. I don't know, I don't know if I how to read that, but if you have a 10-second video, it's much easier to learn that information in the video. Um, I feel that this is why it gets interesting. Um, Video, almost like the world we live in, it has immersed like a lot of potential. Like you can think about a robot. Imagine like have a thinking or planning in their head in a video form. Like that's actually what we do as well. Like when we think about planning a trip or even cooking, we can imagine things before it was done. We can imagine the end, or we can anticipate certain events happening using our ability to visual reasoning. Um, so I think this is why this work can really fit into where how the AI agent can go in the future. Um, but I think along the way, we make it useful, pay the bills. But down the road, I do see this can be a more important integral part of the entire AGI roadmap.
That's very cool. Actually, given again, like sorry, my very common questions I always like to ask, especially to experts who have a lot of domain expertise here. Uh, where did you see like the biggest challenges when it comes to video generation right
Right.
now, from like technical perspective, or even like a
Video
business perspective?
generation.
Yeah.
Yes. So depends that the challenge depends on where you use it for, right?
Hmm.
And if you use it for movies, then the challenge will be, do you have the copyright of the training data? Do you have the IP? Do you make sure, and also control? Like movie directors can control almost everything. They can control actor, they control the settings, they control the camera, they control everything. Therefore, the biggest difficulties for video generation model for directors is control. Now, if you for average users, nobody even give you a professional camera, you probably wouldn't know how to use it. Or even you know how to use it, you don't know how to tell a story using like lens language, the camera language. So now for them, the challenge will be, it's the quality of the generation. Is it cool? Is it funny? Is it just what they want and it's viral, can be shared on the social media. Now they have a very, very different requirements. Whereas if you go even push further for embedded agents or for AGI to do planning, to reasoning, now that's actually you don't need really, really accurate world model. Because if you think about humans, when we say human mind, when we're using planning, we don't have a perfect reasoning model in our head. We don't have a physics engine in our head. We can predict things like say like there's a cup fall from and then the apple fall from our hand and the ground. We can imagine that video in our head, but that speed is not physically accurate. I can guarantee you don't believe Newton's law when that happens. But you know the consequence. You know it's going to land on the ground, you're going to bounce a little bit and roll somewhere, but that's probably good enough. You get the gist of it, and that's good enough for you to do a lot of planning. You say you don't roll the apple, don't throw the apple, or something like that. So I guess the difficulties really depends on where the use case are. Right now, I think a lot of emphasis is on professional filmmaking or amateur or social media. Therefore, the first two are the parts that we focus on. But if you're going down the route of visual reasoning, maybe speed is more important. Like you cannot stand there daydreaming about what's going to happen next until you make action.
That's awesome. Yeah, really appreciate it. I honestly, I think the last piece was definitely, like owning the experts who are working on this daily know those details about where we are in terms of video generation and its challenges for each of the use cases. That's awesome. As we are at time right now, actually, but I also wanna just know if there's any last, wisdoms or any last thoughts you want to share.
Yeah,
Yeah,
no.
go
So
ahead.
actually, I have a very interesting question to ask. I think for many years, for last 8 years, transformer is actually dominant, architecture people use it. But from last Google I/O, which happened months ago, Gemini actually used diffusion model to generate this.
Yes. Not many
What's your
people
opinion on
notice
that
that.
part? Yeah.
Yes.
I can definitely say, this actually improves the token output from quadratic to linear, I mean, faster, what's your opinion to that,
Yes, I think both method has its benefits, right? Like right now, the diffusion text generation, text diffusion model has this global view of things. So we kind of match how humans think about writing code. Like you can write skeleton code and fill the details, which in line with how human programmers write code, right? There's beauty in have a plan first and then execute. So in a lot of the thinking models, they kind of do that. They have a plan and execute. But in diffusion model, this is kind of built in. This feature is built in the denoising process. We generate the high level features first, and then we fill the detail later on. So I feel there's benefit in doing it that way. However, it also has drawbacks, right? We have a fixed window. We cannot generate infinite long. The window is only that big. Um, so I feel that's why the research is interesting, right? We should have both options around and let the history decide which one is better. Um, and I think maybe in the future it's going to be a combination of both. If the world AGI turns out to be just a big large language model, I feel that'll be very disappointing. I hope there's more to that. Yeah.
Yeah. Oh my God, you touched a point where I really want to ask you more questions, even about like alignments and all the things. But unfortunately, today's
Yes.
we already
Yeah.
used the 1 hour and the 3 minutes of your time. So
Yes.
thank you so much
Thank you.
for like sharing your insights. But anyways, any final takeaways, final
Final
thoughts you want to share?
takeaway. I think people don't too fixate on what's successful right now. I think it feels like that way because all the money and all the attention is on certain type of things. But maybe that feels like that at least right now. But we should not afraid to reinvent things. Like, for example, when I started doing NLP, it's LSTM. Everyone's doing LSTM. And LSTM is not good enough. We need to add attention to LSTM. And that's still not enough. We do it by LSTM. Now you can see the line with by LSTM with attention get very, very close to transformer. There's a gradual transition towards that line. But it still requires someone to really think about, take a step back. Like, what are you doing there? Like, why by LSTM with attention works better, right? So this is what I feel where we are right now. We have a transformer, which is a good thing, but how do we support long context? How do we support reasoning? I know that. When we start making a lot of changes on top of transformer, I feel maybe we are at the time we are one step away from a big revolutionary moment where it requires you to take a step back and look at the transformer from that perspective to say, what am I doing? Why all these things that make sense? Maybe I should do something more fundamental change to all the underlying structure. So yeah, that's my final wisdom, I guess.
Yeah,
Yeah.
I feel like that part is very interesting because how the evolve from LSTM to transformer is also trial and error, a lot tons of trial error.
Yeah.
This if you think about all the algorithm designs there, ReLU, this batch layer, this part is tons of trial and error. Maybe you just need another agent, another AI help you to do the trial and error,
Yes.
invent a new architecture, make it smarter.
Yes. If you have infinite compute, then the agent can write code, run operations, and find the next transformer, maybe.
I'm glad we touched the title of or the theme of today's episode is the rise of a agentic internet. So agent, well, probably help you to solve this problem. Who knows? Anyways, thank you so much, Nelson. Again, today really appreciate the time and all the great observations and experience you had over the past decades in the AI space. Super exciting to chat with you again. And we should discuss more.
Yeah, thank you. Thanks for having me. Yeah.
Thank you.
Glad to be
Have
here.
a good day.
Thank you.
Bye.
Bye.